When you're working on a tanker, it's often the things you can't see that pose the biggest threat. Today, we're diving into one of the most critical of these, the invisible hazard of static electricity. And look, this isn't just some textbook stuff. Truly understanding how to control it is absolutely essential for keeping every single operation and every person on board safe. Yep, you guessed it, static electricity. It's this silent, invisible force that builds up during the most normal, everyday jobs, loading cargo, cleaning out a tank, even just taking a quick sample. But if you get it wrong in a flammable atmosphere, well, the result can be absolutely catastrophic. So let's break down exactly how to get it right every single time. All right, here's our game plan. First, we're going to define this invisible hazard. Then we'll get into the different types of static discharges, the sparks. After that, we'll pinpoint the cargoes and operations that are the highest risk. Then comes the important part, the mandatory safety precautions you have to follow. And finally, we'll look at some really clear real-world examples of good versus bad practices. Okay, so first things first. To beat this thing, you've got to know what you're up against. So what exactly is this invisible hazard we keep talking about? At its very core, it's all about imbalance. Think of it like this. Everything in the world wants to be electrically neutral, balanced. Static electricity is what happens when that balance gets thrown way off, and an object starts collecting way too much positive or negative charge. It's that buildup, that pent-up energy that's just itching for a way to release itself, and that release is where the danger really comes from. So where does all this charge even come from? Well, it's happening all around us during our daily work. Every time cargo is just flowing through a pipe, that friction is generating a charge. You've got water or maybe some rust settling down through the cargo. Yep, that generates a charge. And that initial fill, when everything's splashing around and turbulent, man, that's a massive static generator. Even something as simple as a synthetic rope rubbing against something creates static. These aren't unusual events, they're literally part of the job. Okay, so you've got all this charge built up. It's not just going to sit there forever, right? It needs to go somewhere. That release of energy is what we call a discharge, and it can happen in 4 different ways, each one with a totally different level of risk. Let's take a look at this breakdown. Up top, you've got a corona discharge. It's low energy, pretty diffuse, not a huge worry for us. But as we go down the list, things get serious fast. A brush discharge, that can definitely ignite vapors. Now, the 2 we absolutely positively have to prevent are the spark and the propagating brush discharge. A spark jumping between 2 conductors, say a tool you're holding and the tank wall, that has more than enough energy to ignite any flammable mixture. And a propagating brush is even more powerful. Basically, all of our safety procedures are designed specifically to stop these 2 from ever happening. All right, so the science is one thing, but what really matters is applying it on deck, right? We need to know where these risks pop up in our day-to-day work. Which cargoes and which operations need our full, undivided attention. Okay, here is a number you absolutely need to remember. 50 picosiemens per meter. Now, what on earth does that mean? Just think of it as a cutoff line. It measures how well a liquid lets electricity flow through it. Any cargo with conductivity below 50 is what we call a static accumulator. Basically, instead of letting the charge dissipate, the oil acts like a sponge for static, just soaking it up and holding on tight, letting it build to really dangerous levels. And look, we're not talking about some rare, exotic chemicals here. This is the stuff we handle all the time. Jet fuels, gasoline, diesel, you name it. The rule of thumb is simple. Unless you know for an absolute fact that a cargo has been treated with an anti-static additive, you must treat it as a static accumulator. No exceptions. So you've got these high-risk cargoes. When does the situation get really dicey? It's when you mix them with a flammable atmosphere. Any operation involving one of these static accumulators in a tank that is not inerted, that's a huge red flag. Loading, dipping, sampling, tank washing, any of them. You've got the fuel from the vapor, you've got the oxygen from the air, and then static electricity provides that potential ignition source. It is the perfect storm for a disaster. Okay, we've laid out the problem pretty clearly. Now let's talk about how we stop it from ever happening. And these aren't just suggestions or good ideas. These are mandatory, non-negotiable precautions that are our main line of defense. All right, burn this number into your brain, 1 meter per second. This is probably one of the most important rules we're going to cover. It's the absolute maximum speed the cargo can be flowing at when you start loading a static accumulator. Why so slow? It's all about minimizing that initial splashing and turbulence because that's what generates the most static charge. And you can't just speed things up whenever you feel like it. You have to stick to that slow 1 meter per second rate until a few very specific things happen. You keep it slow until that filling pipe is well and truly submerged. We're talking twice its diameter. And you wait until all that violent splashing on the surface has completely settled down. Only then is it safe to slowly start increasing the flow. Starting slow is not optional. Now take a look at this. This little piece of gear is an insulating flange. It's kind of funny because normally we want to bond everything together to make sure it's all at the same electrical potential. But right here at the ship-to-shore connection, we need to do the exact opposite. We need to create a deliberate electrical break to stop any stray currents from jumping between the shore and the ship. This flange is a critical safety barrier. And that same idea carries over to your hose strings. On the left here, you can see the only ways you're allowed to set them up. On the right, that's what's absolutely forbidden. The big mistake here? Using more than one insulating section. If you do that, you create this isolated metal island in the middle of the line that isn't bonded to anything. It's just a perfect spot for a massive static charge to build up with nowhere to go. It's a time bomb. This next one is a simple, absolute, no exceptions rule. Never use ropes or tapes made of synthetic materials like polypropylene to lower any equipment into a cargo tank. Why? Because that stuff is fantastic at generating static. Just rubbing it creates a big charge. Dropping gear into a flammable atmosphere on a synthetic rope is just asking for a disaster. Don't ever do it. All right, let's bring it all home and look at what this stuff actually looks like on deck. This is where we see the theory put into practice. The right way and the dangerously wrong way. I mean, come on. The difference here is just night and day, isn't it? On the left, that's what you want to see, a clean, tight, secure metal-to-metal connection. You know that bond is working. But on the right, what is that? A rusty, painted-over connection with a flimsy clamp? That bond is completely useless. It gives you a false sense of security, which is almost more dangerous than no bond at all. This rule right here is super important, and it's all about dipping, olaging, and sampling. See, after you finish loading a static accumulator, the charge inside that tank doesn't just disappear instantly. The tank is still, well, electrically hot. That charge needs time to relax, to settle down, and dissipate to the grounded walls of the tank. That's what the mandatory 30-minute waiting period is for. It's a relaxation time. If you break this rule, you're sticking a metal conductor into a charged, flammable space. You just have to wait. So let's wrap this up with a final gut check question for you. You've just finished loading one of these static accumulator cargoes. You're getting ready to go take a sample. What is the very first thing you do before you even touch the sampler? You check your watch. Has it been 30 minutes since loading stopped? That simple habit, that one final check, is what turns all of this knowledge into something that actually saves lives.